Hi guys, so this is our third video for week 4. There's no new content in here. I'm just going to go over some of the chapter 5 homeworks. Some of them you were assigned, some of them you were not assigned, but I feel like since we're not in front of each other and we don't have a chance to have some back and forth on the lectures, then I can kind of pick out where some of the trouble points might be in the lectures, the video lectures. And so I just want to go over some chapter 5 homework problems. Now I've already gone over chapter 1, 2, 3, and 4 homework problems similar to this. So make sure you watch those videos as well. So chapter 5, some homework problems. This would be number 6 in chapter 5, so 5.6 if you will. It says identify each of the following. So these are all in nuclear symbol notation, where the top one is A, the mass number, and the bottom one is Z. So for the first one, it is a proton. It's just an H. It's got an atomic number of 1. The bottom one, B, has an atomic number 35. That's Br. Now, C, you cannot do unless you have kind of seen the videos on chapter 5, of course. This is a gamma ray. It has no atomic number and no mass number, all right? Or the numbers are 0. And then D, you look at the 26. So in all of these, A, B, C, and D, I looked at the bottom number Z, because Z is my atomic number and it will tell me what it is. Sometimes you can't do that if it's a beta particle or if it's a gamma ray, all right? Next problem is number 13A and 14A. I'm going to combine them because the instructions are the same. It says, write a balanced nuclear equation for the alpha decay of each of the following radioactive isotopes. Alpha decay, we have learned in week 4 videos 1 and 2, is an alpha particle or a helium nucleus, 42He. So for 13A, we have 20884 polonium. We have polonium 208. And we are going to produce an alpha particle, 42He. So if you add up the A's and the Z's on the left and the right, we're left with we have to create 20482 Pb. All right, curium 243, we have to translate that hyphen notation of curium 243 into the nuclear symbol notation, and then make sure the A's and the Z's on the left equal the A's and the Z's on the right. All right, now top of page 2, this is number 16, C and D. This was not assigned, but it's definitely worth doing because it will help you with some of the assigned problems. All right, so question number 16, C and D. It says, write a balanced nuclear equation for the beta decay of the following reactions. Now, beta decay, we have learned, is the production of an electron or a beta particle. So an electron is the same thing as a beta particle, and beta decay reactions are when we're producing a beta particle or an electron. So for C, potassium 42, that's in hyphen notation. I immediately put it into nuclear symbol notation, which is 4219K. I'm going to produce a beta particle, which is an electron. And the electron has a charge, Z, of -1. So that's why it's down there. So the -1 on the right means I have to have a 20 to bring it to the 19 that equals on the left. For barium 141, if I produce a beta particle, I am left with a second product of lanthanum 141, which is 14157 La. The A's and the Z's, okay? The A's on top, the Z, they have to be equal on the left and on the right of each equation. 32, this was also not assigned, but my guess is maybe 31 was, so this will be helpful. It says, a sample of sodium 24, hyphen notation, right, for the isotope, a sample of sodium 24 with an activity of 12 millicuries has a half-life of 15 hours. What is the activity after each of the following intervals? All right, don't worry too much about the activity of 12 millicuries and what that unit means. Just know that that's how much radioactivity it has at the very beginning. So after one half-life, remember we've learned that half-life is how much is left after one half-life, half of the original amount is left. If half the original amount is left, then it's going to have half the amount of activity. So for A, it's 6 millicuries. And if you do 2 half-lives, well, then you have 3 millicuries. That's our answer for the second part. Now C and D, this is the same question. After 3 half-lives, the activity has gone from 12. 1 half-life brings it down to 6. Second half-life, we only have an activity of 3 millicuries. After the third half-life, we're left with only an activity of 1.5 millicuries. All right, 2.5 days. Well, this is not put into hours, and we need to kind of convert it into hours and then convert it into half-lives. We have to find out what 2.5 days means. Start with what you're given, put it over 1. For every 2.5 days, there's 1 day for 24 hours. 15 hours is equal to 1 half-life. We have 4 half-lives here. If you look at your answer to C, 1.5, you just do 1 more half-life, which is why you have 0.75 millicuries, little m, big C, little I. That just means it has that much radioactivity left. All right, this is question 44 from chapter 5, so this is 544. It was not assigned, but it's certainly helpful. In a fission reaction, okay, fission is when we take a big nuclide and we split it into 2 smaller nuclides, plus usually some side products. In a fission reaction, uranium-235 bombarded with a neutron produces strontium-94, another small nucleus similar to strontium-94, and 3 neutrons. Write the balanced nuclear equation. All right, so what are we given here? Well, we're given uranium-235. We should probably write that into nuclear symbol notation. We're given strontium-94 as a product. We should probably write that in nuclear symbol notation. If you're wondering where I get the 92 for U and the 38 for SR, periodic table, right? That's the atomic number for U, atomic number for SR. It says I get 3 neutrons. So 1 neutron plus 1 neutron plus 1 neutron. So it's customary to write 3 parentheses with the neutrons. Now, on the left-hand side, the reactants, I have a total A of 236, a total Z of 92. So on the right-hand side, I have to have a total A of 236, total Z of 92. You just fill in the voids. What's missing on the top row? 139. What's missing on the bottom? 54. 54, go to the periodic table because 54 is Z, atomic number, and it's xenon. Okay. All right. This is question number 64. 64 asks the following question. It says, complete each of the following nuclear equations. A, so we're going to fill something in there, in that box. Something plus 5927 cobalt yields 5625 manganese plus an alpha particle, which is the 4,2 helium. So another way to read this is one of the reactants is cobalt 59, one of the products is manganese 56, the other product being helium 4. So you just add up your A's on the left and right hand side, you add up your Z's, and we have no choice but to fill in a neutron, 10N, as our answer for A. Very similarly, the total A's on the right for B are 14, and the total Z's on the right is 6. So my answer to B has to be 14,6, and that's carbon 14. All right, see, B is an example of beta particle production, and A was an example of alpha particle production. C looks like it's going to be something called electron capture. That's just where electron or a beta particle. In my notes, sometimes I don't use an E, I use a little beta symbol. But we have an electron plus krypton 76. So the total on the top is 76 as a product. Total on the bottom is 35. Br with a 7635. 80. Write the balanced nuclear equation for each of the radioactive emissions. All right, radioactive emissions, nuclear equation, nuclear decay process, nuclear fission reaction. These are all chapter 5 type terminology for just a chemical reaction. All right, so A, we have an alpha particle made from something called GD-148. Well, that's an abbreviated hyphen notation. We go look up GD. It's 64 on the atomic for its atomic number, and we can write the equation just like we see in the box because an alpha particle is 4,2. So we're left with that SM as our byproduct. As our major second product. All right, for B, we are producing a beta particle from strontium-90. So the first thing we have to do is convert strontium-90, convert that isotope from hyphen notation into nuclear symbol notation. So it's 9038 SR because strontium is atomic number 38. And then I set it up over here. I produce my beta particle, and I look at what's left. I got to have a 90 and a 39 to make Y. So Y is actually an element on the periodic table. Most of us haven't heard of it before. I believe it's called yttrium. It's got a very weird spelling like YT or something like that. All right. The A's on top and the Z's on the bottom are conserved. All right. That's it for the homework problems. Now, how to study for exam number 1. I'm going to go over all of this in when we meet face-to-face at our next Zoom lecture. I just want to say a blurb here because this is a short enough video. How to study for exam number 1. First of all, exam number 1 is chapters 1 through 5 from your book. Okay, that means you got homework problems for 1, 2, 3, 4, and 5. All right, so what to do? Well, I've been giving you video lectures, right? But from the outset, I said you should watch the video through the first time, watch the video the second time, and write the same notes that I'm writing. That way the notes become your own. When you write something down, something miraculous happens where you are able to better retain the information than just watching it or just reading it. That's my opinion. All right. So reread your notes. Number 2, rewrite your notes on the parts that are difficult. You've already written out all the notes. So I'm on number 2 here. Rewrite your notes on the parts that are difficult. Number 3, rewrite out all the sample problems that I've done in the notes. Because I'm going to test you not just on the notes, but also on all the homework problems in the notes, but all of the sample problems that I do in the video lectures. So it's important to know that as well. And we'll talk more about this when we meet in a couple days on Zoom. All right? All right, that's it.